Hey guys, I hope you're all doing well. This is going to be the last video. That is 8-3 quadratic functions in standard form. We talked about vertex form already. We talked about why vertex form is good. When a quadratic equation is in vertex form, the good thing about that is you can see the vertex right in the actual form itself. In standard form, there's standard form's a little different. It's f of x equals ax squared plus bx plus c. We talked about that before, how a quadratic equation looks in standard form. Standard form is good, has its values also. We're going to talk about what C does in standard form. What is C in standard form? What is this constant term in standard form? We have the coefficients A and B are for the coefficients of x squared and x, but C is the constant term. What does C do in standard form? So example 1 talks about relate C to the graph of f of x equals ax squared plus bx plus c. So we have three functions here, and I graphed all three of them. And we want to see what C does. What is C in the actual graph itself? So if you look this function here, f of x equals negative 2x squared plus 4x minus 3. And C is negative 3. Well, when we graph it, this is the graph of this function. We'll learn how to graph these functions in example 2. But for now, when we graph this, you see this is the graph of the first function. The second function is negative 2x squared plus 4x minus 1. Here's the graph of that. The third graph is f of x equals negative 2x squared plus 4x plus 1. Here's the graph of that. If we look at what C does, you can see C is negative 3 here, it's negative 1 here, and it's positive 1 here, C. If we look, okay, so C must be, what is this point here where it crosses the y-axis? Yes, it's the y-intercept, right? We learned that before. Wherever the graph crosses the y-axis is called the y-intercept. So that's what we have so far. So can you see how that relates? Okay, so C is negative 3 here. The y-intercept is negative 3. C here is negative 1. The y-intercept is negative 1. The C term here is 1. And the y-intercept is positive 1. So again, C tells you, in standard form, C tells you the y-intercept. When the graph's in vertex form, you can't really tell what the y-intercept is unless you put it in standard form, which we'll do in example 4, I believe. We're skipping example 3, by the way. We're doing section 8-3. We're skipping example 3. So now that you see this, we're talking about the value of C is the y-intercept every single time when it's in standard form. So go ahead and you can try example 1, page 176 of your workbook. Okay, I'm going to continue. You can pause the video and do try example 1. I'm skipping, well, here's example 2. I did it on graph paper. Example 2 says, how do you graph an equation, a function that's in standard form? Ax squared plus bx plus c. So let me make sure I get the whole paper here. Yeah. Okay, let's go ahead and graph that function. There's a few steps that we have to follow. And the step 3 and 4 are very similar, are exactly like the step 3 and 4 when we graph equations in vertex form. So in standard form, what we're going to do is we're going to find the axis of symmetry, the vertex, and the y-intercept. The y-intercept is pretty easy. At C, we just learned that. The axis of symmetry, how do you find the axis of symmetry? This is important. This is the formula to find axis of symmetry, or the line of symmetry. That's the line that divides the parabola into two equal parts. And the formula is something we have to memorize. It's x equals negative b over 2a, where b is the coefficient of x, a is the coefficient of a in standard form. Okay, so let's go ahead and find, step 1, find the axis of symmetry. Let's do that. So x equals, we know a equals 2 in this function, 2x squared plus 4x plus 3, that's what we're graphing. A equals 2, b equals positive 4, and c equals positive 3. So we know those three things now. But we only need a and b for finding the line of symmetry. The opposite of b over 2 times a. B is 4, a is 2. What's the opposite of 4? Negative 4. 2 times 2 is 4. What's negative 4 divided by 4? Negative 1. X equals negative 1 is the line of symmetry or axis of symmetry. Okay, that's what we know. I can actually start by graphing that right now. Line of symmetry is x equals 1. I'm going to do that in red. X equals -1, sorry. So I'm going to go find -1 on the x-axis, and I'm going to draw a vertical line right through there. And make sure it's dashed, because dash tells you it's just a line of symmetry. It's not part of the graph. It's just helping us graph it. This is the line of symmetry or axis of symmetry. So we did that already. That's step 1. Well, the line of symmetry is also the x-coordinate of the vertex. So we also know that. Find the vertex is step 2. Since we have the x-coordinate of the vertex, we can use that to find the y-coordinate of the vertex by plugging -1 in for x in the function. So I'm going to find f of -1. That's going to give me the y-coordinate of the vertex. The next step is to find the vertex. So we have finding the axis of symmetry is also the x-coordinate of the vertex, because the vertex always lands on the line of symmetry or axis of symmetry. Let's go ahead and do that. Do the math. -1 squared. Replace x with -1 everywhere you see an x, and do the math. -1 squared is +1. 1 times 2 is 2. -1 times 4 is -4. And then plus 3. What's 2 minus 4? 2 minus 4 is -2. -2 plus 3 is +1. So +1 is the y-coordinate of the vertex. Now we got the vertex. We found the line of symmetry. Now we found the vertex. The vertex is -1, 1. Let's go down here and plot it now, since we already did it. So -1, +1. There is your vertex right there. Put a dot there. Okay? Since A is positive, we know what about the graph? Is it going to open up or down? Since A is positive too, it's going to open upwards. So that's what we know. That's something to know. Okay? Now, to finish this graph, remember we need 5 points. To finish this graph, what we want to do is we want to pick 2 x values either to the right or to the left of the line of symmetry. The line of symmetry is at -1. So we want to pick 0 or 1, or we can pick -2, -3. You see how I picked 2 x values to the right or to the left. Doesn't matter which ones. But they both have to be on the same side. So I can pick 0, 1, or I can pick -2, -3. I can plug them in, make a little table, plug them in, and then find the y value, so I can find 2 points on one side. Once I find 2 points on one side, that's 3 points. I gotta reflect those 2 points. And when I reflect those 2 points, that's gonna be a total of 5 points. We need 5 points at least to graph these functions. Let's put 0 in the function. So replace, so you can do that on a calculator. Let me show you how to do that on a calculator. Let's replace 0. So 2, this is probably the best way to do it. Parentheses 0, parentheses squared. There's a square button. Plus 4, parentheses 0, parentheses, plus 3. Enter. It'll do order of operation for you. The answer was 3. So when x is 0, the f of x is 3. Let's plug 1 in here now, into that function. 2 times +1, parentheses 1, parentheses. Here you plug it in exactly how you see it, and then you should get the answer. 4 times 1, parentheses, parentheses, plus 3. Enter. And then the answer is 9. Okay, let me plug -2 and -3. You know what, let me go ahead and graph these first and then see what happens. 0, 3. Isn't that the y-intercept? 0, 3. Isn't that the y-intercept right there? Wow, isn't that funny? That's the y-intercept. Okay, so the y-intercept is 3. We know that too. They wanted us to find a y-intercept too, so we say the y-intercept is 3. 0, 3, that is. And then 1, 9, 1, 9. So I got 3 points. To finish this graph, I'm simply going to reflect these 2 points across the line of symmetry. So to reflect them, you just have to find the distance from the line of symmetry to the point and make sure it's the same distance from the line of symmetry to the other side of the line of symmetry. So this point is 1 unit to the right. The reflection is going to be 1 unit to the left. That's that point. This point is 2 units to the right of the line of symmetry. So the reflection across the line of symmetry is going to be 2 units to the left. There you go. We got 5 points. That's it. The vertex and 4 other points. Now go ahead and draw your parabola, and that's it. We're done. I'm going to go ahead and find these 2 points. I bet you this is going to be 3 and this is going to be 9. Let's plug -2 into that function, and then plug -3 into that function just to make sure. So 2 parentheses -2 parentheses squared plus 4 parentheses -2 parentheses plus 3. Enter. 3. The answer is 3. Yeah, that was right. 3. Let's see, -2, 3. Let's see if it's right. -2, 3. Yeah, that was right. Let's plug -3 in. I bet you it's going to be 9. Positive 9, this answer. Let's plug it in. Go back to the function. 2 parentheses -3 parentheses squared plus 4 parentheses -3 parentheses plus 3. I'm replacing x with -3. And it was positive 9. It was positive 9. So I didn't even have to graph these two. I would have got -3, 9 and -2, 3 either way. So again, you can pick either 2 points to the left of the line of symmetry or 2 points to the right of the line of symmetry. Left or right, doesn't matter. Left or right is the left, is the right. Plot those 2 points and then reflect them across the line of symmetry. You won't have to find all 4 points. Vertex and 2 points on one side, that's 3. Reflect those 2 points. You got a total of 5 points. We need 5 points. Okay, now that we did this, I want you to try example 2A and B, page 176 of your workbook. There's a graph there for you. Go ahead and do them. Use these 4-step method. Again, step 3 and 4 are identical to step 3 and 4 of when we had it in vertex form. The only difference was step 1 and 2 was different because in vertex form, you don't have to find the vertex. The vertex is right there. Okay, very good. Okay, I'm going to skip example 3 now. We're going to go right to example 4. Let me make sure this thing is lined up right. I think I'm going to zoom in a little bit more. Yeah. Okay, example 4. We skipped example 3. Example 4 is a little story problem. It has. I want you to go to the book on page 332 and look at the graph that's there. I didn't want to draw the drawing. It's already in the book. And you have Mia tosses a ball into the air. This function, f of x equals -0.5 parentheses x minus 2 squared plus 8 represents the ball's path. This function is in vertex form. I can tell because of the parentheses and the square right there. This is vertex form. The question is, what does vertex form tell us about the situation? The ball's path. Well, let's see. Let's find the vertex and find out what's going on. Well, if it's in vertex form, finding the vertex is very easy. The x-coordinate of the vertex is h. Use the black pen. H, comma, and then k is the y-coordinate of the vertex, and they're always right here. The x-coordinate is +2. Remember, h is the opposite of what it looks like. Since it's -2, it's +2. Minus h, -2, +2. And the y-coordinate is exactly what it is. If it's -8, it would have been -8. If it's +8, it's +8. So 2, 8 is the actual vertex. Well, what that tells me is if the ball got thrown in the air, the vertex is either the highest or lowest point, then it hits the ground. So the vertex is either the highest or lowest point. This is the vertex right here. The x-coordinate of the vertex, what does it tell us? What does the y-coordinate of the vertex tell us? Well, here's what it tells us. It tells us that 8 feet in the air, the ball reaches a maximum height of 8 feet in the air. That's the y-coordinate. This number tells you how high it is on the air. That's the y-coordinate, is vertical. This tells you how far away it is from the person that threw it. So it's 2 feet away from Mia. Let's say this is 0. This is the x-axis. It's 2 feet away from 0, from Mia. Here's Mia right here. Again, I didn't want to draw it. You can see the drawing in the book. It's better. So she throws the ball in the air. It reaches a maximum height of 8 feet. This point here is 8 feet, and that's 2. That's what it tells us. So it tells us the maximum height of 8 feet. The ball reaches a maximum height of 8 feet in the air after 2 seconds. This tells us time. X is time in this case. Okay, so the ball reaches a maximum height of 8 feet after, and X is time, 2 seconds. That's what the vertex tells us. It gives us information about what happened as she threw the ball in the air. So then, what does the standard form tell us about the situation? Remember, she threw the ball at 6 feet in the air. Remember that. So in order to answer part B, we have to change this into standard form. To change this to standard form, we got to do order of operation. We're not going to distribute first. Because of the square here, we have to do exponents before we multiply. So exponents comes first. So how do you do x minus 2 squared? Remember, x minus 2 times x minus 2? You can do box method or distributive property, whatever you want to do. X times x is x squared, negative 2x, multiply, remember? Negative 2 times negative 2 is positive 4. Add all together, you get x squared minus 4x plus 4. That's going to be, this is what x minus 2 squared equals. Okay? So let's plug that in here now. So f of x, I'm changing standard vertex form to standard form, equals negative 0.5. And then x minus 2 squared is, we just learned that was x squared minus 4x plus 4. Then don't forget about the plus 8. Now, it's still not in standard form. To get in standard form, order of operation says distributive property first, and then move from there. Multiply everything by negative 0.5 in parentheses. Negative 0.5 x squared minus negative 0.5 times negative 4 is plus 2x. Negative 0.5 times 4 is minus 2 plus 8. Are there any like terms? These are like terms. Add them together. And then it's in standard form. Negative 0.5 x squared plus 2x. Negative 2 plus 8 is plus 6. We just change it to standard form. What does standard form tell us? Remember C in standard form tells us the y-intercept? In this case, the y-intercept, if you look at the graph in the book, or you look at this graph, the y-intercept is the initial height of the ball when it let go of her hand. So the y-intercept. C tells us, standard form gives us the y-intercept. Standard form gives us the y-intercept, which is 6 feet. It tells us the initial height of the ball when it left her hand. Initial height of ball when it left her hand. Okay, so the vertex gives us the maximum height of the ball after 2 seconds, 8 feet in the air. That's what the vertex tells us. In standard form gives us the y-intercept. You can see the y-intercept right away. You can still get the vertex from standard form by doing negative b over 2a and then plugging back in the x value and finding the y value, like we did when we graphed it in standard form. But that will take a little longer. But in standard form, you can see the y-intercept. That's the initial height of the ball when it left her hand. It left her hand when she was 6 feet in the air. It reached the maximum height of 8 feet in the air after 2 seconds, and it fell back down. So the x-coordinate is time in seconds. The y-coordinate, or the y-axis, is the height of the ball in feet above ground. Okay, now that you did that, we did the example 4. Do the try it example 4, page 177 of the workbook. When you finish that, I want you to do you understand in the workbook, number 5 through 9 on page 178 of the workbook. It's going to be very important in Algebra 2 that you know how to graph quadratic equations in standard and in vertex form. Graphing them is very important, and understanding this problem is really important too, because we're going to do a lot of that in Algebra 2. Okay, go ahead and do that. The homework will be coming soon. Thank you.